Hi everyone and welcome to this new video. In this video we analyze a challenge taken from the recent LAF CTF. So this CTF happened between Friday and Saturday, 27 and 28 of December. And I just want to bring this one because it's a web challenge and it's based on Clojure, which is a dialect of Lisp. I really like Lisp as a language, so it was fun because it was a kind of challenge where the challenge itself was not hard. However, we are given to analyze Lisp code, so we need to understand how to read Lisp code and how to think about security in languages that are more exotic than your usual language. So let's go into the content itself. So we have a challenge file, this LAF manifesto. The challenge is called manifesto. We can unzip it, and here we get all the files of the challenge. Now, as always, the cool thing about this challenge is that we have a Docker file, and we can build a Docker. So actually, let's just build a Docker already. I just like to call this Docker's chal. Okay, it's already built because I was already building it. So the image is already ready. And we can just run the Docker. So I usually use the flag dit. Then I say the port here. The port I believe is 80. Okay. Then I have port 80. Actually, let's say 133.780. And I do just chal, essentially. So I have run the Docker. Also, in the Docker file, we can see that the flag is exported as an environment variable within the container. So if we get a way to execute code, we need to extract the variables. I mean, even if we don't get to get code execution, we still need to somehow understand how to extract variables because it is a variable in the container and we can check it with a simple. So actually I need sudo for this. Then I'm gonna need to execute a command. So I'm gonna do execute the bash command within the challenge. I think it's called, no, I didn't give it a name. I did not give it a name. So I'm just gonna have it here. So this is the container that contains the challenge. And if you do env here, we check as the flag. Here we have the flag. Of course, this is a fake flag, but in the real environment, it's gonna be the real flag. So this is good, perfect. Now, how can we interact with this challenge? Well, here we have essentially all the files of interest. If we do a clock on it, we find that we have a few lines of code of Clojure. So it's just 100 lines, really not that much. So here we have the Clojure project. So here I actually need to install Clojure mod. I can just use package Clojure mod straight T to install it in Emacs. This is gonna take a second. Okay, so now I've installed it and I can do Clojure mod. So this is your typical package file that describes all the dependencies, the name of the project, not really that interesting essentially. So this is okay. And then we find the actual code itself. So actually, let's go back. We have the resources and we have the source. Now in the resources, as we can see here, we have some HTML files in the templates directory. And also we have a style CSS. So essentially, this is your typical public static resources. This is a templates because it's going to use a template engine. So typical way of producing HTML to have dynamic elements with a template engine. In terms of source code, it's just one file. It's in the source manifesto core.clj, which is the extension of Clojure. And here we can see it, manifesto core.clj. And this is essentially Clojure. Now, Clojure is the language that is a more modern dialect of Lisp. So in Lisp is sort of like a macro language of different, it's sort of like a macro family of different languages. For example, I use a lot Emacs Lisp, which is a different dialect of Lisp. And of course, each dialect implements specific things in specific ways, so they are different from each other's. However, the basic idea and the basic syntax is the same all around, and the most important part of Lisp languages is the concept of S expressions, which are in this case these things. Like for example, these def users. This is a so-called S expression. Now in Lisp, everything is actually an S expression. So the first thing we must understand in order to read this code is, okay, everything is an S expression. How are S expressions structured? They are structured in the same way. On this regard, Lisp is a very uniform language. Why? Because S expression always start with a keyword at the beginning, which identifies what kind of S expression we are talking about. For example, an S to define the sort of like namespace, def1s or def to define variables, where here is called def1s, so it's gonna act a little bit different in how the memory for this variable will be treated, and here we have def. Now, to be honest, I don't know the difference, but we can imagine that, okay, maybe def1s adjust with once, while def is gonna change. So that's the idea. Then here I do some configuration. Here we have this selmer.parser set resource path. So in this case, we have a function. So this is an X expression where the first element is the symbol of a function. So in these cases, this you can imagine this as a function call. Even def and def1s you can also imagine as function calls. However, the effect of these function calls is to define new variables. So instead of doing in typical languages where you have like var, equal, and the value, in Lisp, everything is an S expression, so it follows the same structure, where you have identifier and then the arguments. Now, in this case, the arguments for the def is first the name of the variable and then the value itself, while in this other case, we have a different function, which is going to set the resource path for this particular parser. And here we are generating an input-output resource called templates. So that's the idea, because this is going to be the path where the templates are stored. Then we have the records, so def record user. Here is going to be another data structure, and we have a username, password, and gist. That means for each user, we're going to remember these three following things. Then we have two functions, which is called services, insert user and insert gist. Then we have a utility, JSON response. Then we have here, I don't know why it's written like this, password. Not sure what was the point there. Then here we have this S expression on its own, which I do not completely understand why it was put here. Maybe it was a typo, because I don't think it serves any particular value. And then here we have essentially this kind of array in which we define different routes. So I'm not completely 100% familiar with Clojure syntax. However, what's important here is that we have a different function being defined, which is the routes function. And then we define the app itself. And this is where we close this array with the square brackets, with the closed square brackets. So probably they are united in a way. That's what I think. And then at the end, we have the start server, stop server, some convenience, rep shortcuts, and the main itself. So this is the main entry point. So what do we do in the main entry point? Well, we do this do block. In this do block, we do a series of S instructions. So each one is going to execute a different function. So first we insert a user called admin, and with this particular string as password. Because in the insert user function, if you go up here we take two parameters, username and password. Actually, with Clojure, I guess you can also define the same symbol so that it, depending on the number of arguments, you have different implementation. So for example, in this case, we have the first implementation, which works with just username and password, and it's just gonna do an insert user with an empty gist. And the third is that it's also gonna have a list of gist. And from what I can understand, although I'm not 100% sure on this, in this other implementation, essentially it swaps out on the user's data structure, this one on the users, it swaps out the data of this particular username with a new password and gist like updated in a way. But I'm not sure if we use this other kind of version in the insert user. So let's do a quick search. To be honest, we just use it once, so we don't really care about that. Now, in CTF, it is important, and in general, also in code reviews, it is important to understand what is dead code. And with dead code that is dead, we mean code that is not actually actively used by the process. Why is this important? Because dead code in a typical execution will not be touched, will not be used, so we will never have to deal with it. In this case, we only use insert user with two arguments, so we don't really care about the implementation for the third argument version. So that's the idea. Now, this random UED is probably taken from the standard library of Clojure, and I suspect it's gonna just generate exactly a random unique identifier. So we probably, the way to go forward is probably not to guess this value, because we will not be able to do that, but just to do other means. Also, if you just install Clojure, here I install it on my machine with Pacman essentially. So here we can just execute a bunch of instructions to play around. So for example, if you do str of random UID, we obtain this thing. So this is gonna be the password that we assign to the user admin. And we can play with this key to maybe check out some stuff. So that's the idea. Okay, so this is in terms of the first thing is the insert user. Then we insert this gist and we insert to the admin value. So self reminder 1 with Clojure, you get to Clojure. Clojures give me composure. I love Clojure. So 3 different gist, all to the user admin. So we do not have any other user whatsoever. And so after we have created the admin and inserted 3 different gist, we're gonna execute the start server function. Now, what does this function do? In this case, we are just executing here a Jetty server. So it runs on every interface on the port 8080. The thing on port 1337, and it seems to work. So that's good. Why is that works? Let's see the Logger file a bit. So I guess Clojure port 80. Okay, no, there is an environmental variable Clojure port that if set up is gonna use the Clojure port. Okay, so look at this. So here in the port, we define the port and it's gonna say, look, I'm gonna parse as integer whatever the value of this internal S expression is. And this internal S expression could be either taken from the environment or given hard-coded in the code. So this is how you read the Lisp code in general. So what do? Here we have an expression. This expression is gonna say, like, for example, in this case is, okay, whatever is the result of this internal S expression, the output of this bigger one is gonna be an integer. So essentially the idea is that you take the inside one, you understand what it gives you back, like for example, a string, and then you take, okay, this is like calling integer parseInt with a string as an input, as argument. And if we take our shell and we do integer parseInt of any number, but number codified as string, we get back the number itself. So this is the string 5, we're gonna get the number 5 back. Now in this case it's an OR, but let's say that we have an OR of like one value, like OR of 2 or 5. It's gonna get 2, I believe, right? Because it's gonna get the first one. However, if I have an OR of nil or 5, it's gonna get 5, because OR is gonna get the first one that is different than nil. It's gonna return the first value. So with the env here, we are extracting a variable from the environment. Okay, this is a cool instruction to know, because it means that to actually get the flag environment variable, we can do env flag. Now in this case, it should be nil, unable to resolve env in this context. Okay, so in this context, env is not okay, because here we use environ.core refer to env. So we have introduced a specific symbol in this namespace. So instead of doing env, let's do environment.core flag. And it's gonna say, let's see, syntax class not found exception. So it's still not gonna found this. Okay, and in this case, I cannot use this environ.core because it is a library to deal with environmental variables. If I don't have this library, but I still want to access the environmental variables, I can use the system/getenv. So in this case, system/getenv in the context of the challenge should get me what I need, which is the flag itself. So that's the idea. So we start the server, and if I go to the browser, as I was doing before, here I have the website itself, which says the Clojure manifesto. Here I have the different S expression with the different values. This is a simple way to understand S expression. Like in this case, I have plus 1, 2, 3, and it says 6. And notice a particular thing about Lisp languages is that the operator always comes first. In these S expressions, here, for example, we have a plus, like a sum of numbers. We do 1 plus 2 plus 3, which is 6, but the operator plus comes first. This is called prefix notation, where the operator comes first, different from the typical way in which we write, which is called infix, because the operation is between the operands. So this is one of the most powerful things of Lisp because it allows to have a very uniform structure essentially. So in this case, for example, what we can say is we're going to arrange the number from 0 to 5, then we're going to check only those even ones, and we're going to use this filter to say, okay, only the numbers that pass this particular predicate will get picked up to the output. So in this case, 0, 2, and 4, while the odd ones, they're going to be discarded because when we apply the even question mark function to an odd number, it's going to return nil, it's going to return false, and so the filter will just not care about it. But whatever, that's like Lisp stuff. So this is the website. Now, what can we do with it? Well, this is like a pretty regular website, nothing too much, not really much here. And here we have login, we have gist, but it says you do not have enough privileges, and then we can change essentially the style. So we have home, login, and gist. Okay, let's try to understand the code for the API controllers. So this is of course the most juicy part of any application review of a web app, because the controllers is where most logic happens. And in this case, it's not really that much code because we start from the routes, this is the function, and we have until the routes end, which is like what? Not like 100 lines, barely. So let's review this code. We have the index route. So this is what's going to be executed when we match the slash. So when we match essentially, so for example, in this case, let me get back to Chromium. When we match the localhost 1337, we're going to execute this code. So this code is executed. And what does this code do? It prepares a response, and it prepares the response by rendering the file index.html. And when it renders the file index.html, it's actually going to use a couple of variables because this is using a template engine. So in this case, if we check the template, so manifest source resources templates index. So essentially here we have this typical like template syntax, and here we have, for example, let's see, what do we have here? Any specific variables? We have the layout.html. In the layout.html, we have the username field, and we also have the prefer, like there's also some conditional. So if prefer is equal to light, then else, and stuff like that. So these are parameters. So let's see where we obtain these parameters. Now the username parameter is obtained from the session. When we see the syntax session username, we are taking stuff from the current session. So this is a piece of data that is available on the server and that is handled by the server. And the prefer instead is given either by the query parameters or by the session. If it's not found in the query parameters or in the session, it's going to be light. The URL is given by the request itself, which here we can find what of the requests we are taking in to parse in the backend essentially. And then, so this is going to do one thing. Now, after we render the file, so after we prepare the response and we send the response, we are still executing something. So at this point, the user received the page. So like in this case, we received the page. Now the next thing is going to do a merge. So it's going to merge the properties, and then it's going to assign this new like object constructed to the session. So essentially, it's going to change the session of the user with new data. Now, how does this merge work? Now, in this case, we are merging the session, so the currently existing session of the user, with the query parameters that the user has provided us. Now, when I was reading this code, at some point, I thought of this. Is there somehow where we, as the user, with our parameters, can change values already present in the session? That is, can we overwrite some session variables? Now, this kind of question is useful to ask regardless of the language and regardless of how much you know the language you're working with. Now in this case, I was not really familiar with Clojure specific APIs. I can read a little bit of Lisp code, but Clojure APIs I've never worked with, so I didn't really know about this merge. Anyways, later it turns out that you actually can, because merge gives preferences to its second parameter here, so actually the third parameter. So if you have something that is both in the in the first object and also in the second, it's going to get overwritten with the value present in the second. So in this case though, what is the thing that is used to check for authentication when we want to go into the gist page? So here it says you do not have enough privileges. Well, when we go into the gist page, what's gonna check is it's gonna extract from the session the username, and it's gonna check if it's different from admin, then you get the error. You get this JSON response with the error, you do not have enough privileges. Otherwise, instead, what's gonna happen? Otherwise, you're gonna get the page itself, and then you're gonna be able to upload the new stuff. So to actually be authenticated, we need to somehow write in the session variable within the key username the value admin. And then I thought, okay, I look at merge documentation, and I was like, okay, if in the query parameters we put a key username with value admin, then when it does this merge, it's gonna put into the session the user admin. So how do we do this? It's very simple actually. We go here, we put the username uguale admin, and look, now it says hey admin, and if you go into gist, we actually get the page. So now we are properly authenticated. So that's the basic idea. Now, this was fun, not because it was complex, it was extremely simple. However, it was fun because you were like, you had to analyze code that you are not familiar with, and you needed like a direction to go. In this case, the direction can be obtained by, okay, understanding that to authenticate, it's gonna check the session, seeing that our user input somehow gets into this merge, which has a suspicious name, because intuitively it's going to be like, okay, merge of what? Of the properties with the session data that is later used to perform authentication. So essentially that's how I manage to discover this first step. Once again, I had a little bit of familiarity with Lisp, but not really with Clojure. So in this case, I was working half blind, I would say. Not completely, because I'm able to read Lisp code, but I had no clue about this kind of Clojure-specific APIs. So this is the first step. Now, the second step has to do with this gist. Now, at this point, we are able to put stuff here, right? We put stuff here, and essentially here we have two methods in the gist page. The request with the get and the request with the post. If we do a get, we're just reading the gist. If we do a post, we are uploading new gist. Now, the cool thing though is that when it's gonna render the gist, what's gonna happen is that in the templating engine, it's actually gonna execute it's like if we go into the resource, templates here into the gist, it's just gonna put the gist itself, right? The gist itself. Now at this point, you might be tempted to perform server-side template injection, so which is a typical attack. So it's called server-side template injection, SSSTI. Why? Because when we are rendering the gist here with this template gist.html, if we go and look at the template itself, here we see that, look, it's gonna be rendered for gist in gist, and the gist here are obtained from the specific user. So we take the session, we take the gist, and then we essentially pass it to the template engine. Now, I was not able to do it with SSSTI after all, and I think it has to do with the specific library that's being used, which is this Selmer parser, which has limited capabilities from what I understand. Anyhow, in this context, it was not about server-side template injection. What it was instead was in the actual creation of the gist. Why? Because the actual creation of the gist, as we can see here, this is done with a post. So essentially what we do is we perform the function insert gist with our username, and we call this function, which is called read string, with the gist, with the string that is here is called the gist. So we perform a read string on our essentially input. So here we control the input, and we are inserting this stuff, and then we can see later the output of this. We can see essentially the output of the read string, because when we put stuff here, we're gonna see the output. Now, I was trying to get some like dynamic execution, and one thing that I noticed, for example, is that if I put @users, I will obtain this expanded thing, which is clojure.core deref users. Now, at this point, I understood that during this read string, some processing would happen. However, not enough to actually execute code. Meaning that read string, like if you open our shell, read string is used to construct a proper Clojure expression starting from a string. So if I do read a string of @test, is gonna actually, let's read the string of @test, is gonna sort of like transform the code. So in input to this function, we give it a string. In output, we obtain an S expression. So this is technically code. However, it's code in a symbolic form. Because in Lisp, not all code is always executed. In Lisp, we can have this space between a string and process, which is like symbolic code. And then we can execute it. So we have a process essentially, like a dynamic execution of a piece of code. So with this read string, we go one step, but we do not get the actual evaluation. There is actually a different function that performs evaluation, which is called eval. So for example, if I have here eval, and here I put the string, the expression plus 2, essentially, this one, I'm gonna get, so in this case, it's an eval of a string. So what I should do is eval of read string of the string plus 2, like this. So in this case, so let's see what got wrong. Okay, here I got wrong one thing. It's eval of read string. Here I open, do plus 2, Here I close the parentheses, here I close the string, and here I put 2 parentheses. So here I'm gonna get 4. So what happened here is that we start with a string, then we transform it into symbolic code, and finally we evaluate that symbolic code. That is how Lisp works, essentially. Now in this case, however, the conundrum was that, okay, I'm able to obtain an S expression that represents code, but I'm not able to truly execute it. So for example, if I do the system getemp, so if I do system, the thing that we saw before, system getemp, so in this case, what was it? It was like system getemp flag, something like that. If I do system getemp flag, like that, it's just gonna be the code itself. I'm not gonna be able to evaluate it. So to actually get code evaluation, after some looking at the documentation, reading online, I found this specific macro, which is a reader macro, which is like this, is this hashtag equal, and then I put the eval, and then I put the system getemp flag, like this. So this is gonna perform read time evaluation. So in this case, I put this, okay, it's not gonna do anything, but if I do, let's say, if I do like this, eval system getemp, here I'm gonna get all the different environmental variables, and I believe that before it did not do anything because I put the wrong name as environmental variable. So it should be eval of system getemp flag capital. And with this, we actually get the flag itself. So without all the different environmental variables. So the payload here was like this hashtag equal eval, and then the code itself to get the flag itself. So when we do this, this is like, it's going to instruct the Clojure to say, okay, when you construct the code, you're going to do an evaluation on this code. Evaluating this code means executing the eval instruction on this thing. And then, so it means that we're going to get the actual string itself. So this challenge was not hard in terms of like complex exploits. However, it did require a little bit of understanding of exotic languages such as Lisp. And to finish off, we can read the xkcd here meme. Lisp is over a half century old and it still has this perfect timeless air about it. I wonder if the cycles will continue forever. A few coders from each new generation rediscovering the Lisp parts. These are your father's parentheses, elegant weapons for a more civilized age. So this is very, very fun, very Lisp. I hope this was like a different video, and I hope that it showed how to approach a code base that you don't really understand. So here it's all about intuition actually. We don't need to understand all the details about this code base. We can just go by intuition, say, okay, look, here I'm somehow merging a user control parameter into a session, which is then used to check for authentication. Here I'm reading another thing from the user, so maybe these are the entry points. And regardless of the way that these things are written in, the processes, the computational processes that they represent are nonetheless the same if you write it in Lisp, if you write it in Java, in Python, in whatever language. At some point, user input has to interact with the logic server, interact with the data stored in the server, and that interaction has to be done in a secure way, which in this case it was not done so. And for example, sometimes it's really like a few things that change everything. Because for example, if in this merge, the query parameters was in the first position, therefore had less priority than the session, this would not have happened. Because even if in the query parameter I put the username, this property was already present in the session, and when the property is present in both objects, the merge is going to prefer the second one. So the session, which was the trusted data. But in this case, it was not. It was our parameters, and so we could control the username of the session, which allowed us to do an authentication bypass. So that's the idea. In terms of vulnerability, here we have authentication bypass, and also we have some primitive form of execution during input. So in this case, it would be improper data validation, but in Lisp, it's really hard because if you just allow any sort of like expression, it's literally impossible to just understand which one is malicious or not. So this is for this video. I hope it was fun, and to the next video.